Welcome everyone. Thanks for being here. My name is Simeon Balabanov. I'm the product manager of Viri for Unreal. Before that, I was part of the 3D department at Chaos Group, visiting customers and working with the product and actually trying to get to know your workflows, guys, and understanding how we can better improve these workflows. And today I'm going to talk about a couple of products and our efforts of going into real time and why we did it, and give you a reasoning about that. First, I'm going to start with Unreal, of course. I'm the product manager, so let's go with that. Viri for Unreal has actually twofold purpose. It's on one hand, it can be thought about users who are already familiar with V-Ray, and it's a mean to transfer your projects, your V-Ray projects, into real time with as much as parity as possible, and to keep the workflow as straightforward as possible. Again, this means keeping V-Ray assets, keeping V-Ray skills, and not having to add too much additional steps. On the other hand, it's you can think about V-Ray for Unreal for non-V-Ray users, because there are lots of users that are already in the Unreal, using Unreal in their everyday workflow, and for them we would like to give the power of the V-Ray ray tracing engine and the renowned lighting methods inside of the engine, be it for high quality renders or for light baking. The benefits that Chaos Group actually goes for in the last couple of years, and we were thinking about, is how can we be a bit more interoperable, how we can allow our users to keep their existing workflows and skills, so that they can just transfer those and save time. Additionally, we want to do so by maximizing parity between going and switching from offline to real time, and as well keep it, of course, easy, because once you learn the way to work around with V-Ray, you should be able to reuse that skill everywhere. And of course, not to mention that the quality that V-Ray is renowned for is propagated, or we want to find a way to propagate that in real time as well. So I'm going to talk about, here are some of the workflows that we feel V-Ray for Unreal and real time is going to be useful, but I'm going to stress on the first one, obviously, for this demo. I'm using a scene provided by an artist called Bertrand Benoit. This is a scene called North South. You can check this out on his TurboSquid account. And this is a scene in 3ds Max. This is what the material setup looks like, light setup, and I'm going to do a quick reference render so that we can see what the artist's intention of this project was. Then I'm going to export a V-Ray scene, and that will be all the preparation from 3ds Max. Now, an important thing that I would like to note is that since V-Ray is available for a multitude of platforms, the majority of these platforms can export VR scenes, and we treat the VR scenes as the universal file format that can bear or transfer geometry, shaders, materials, lights, even cameras. So you can do that from Rhino, Revit, Maya, SketchUp, whatever you want. Here I've created an empty project in Unreal, and I'm just going to hit the import button on the content browser, and in a couple of minutes I've cut the video down because it took something like 10 minutes. I imported the scene, and I'm going to do again a reference render so that we can see how close this project was transferred. Now, the important thing is that this is not a live link to the VR scene. Now everything lives inside of Unreal, and you're free to do whatever modifications you would like to do. So this is a completely new render out there, and as you can see, the transfer has been very successful. The one thing that we see missing is a proper illumination on the right-hand side. This is the Unreal Viewport. And this is because there is no light baking in this case, or no actual shadow tracing or GI. Now I'm going to do something before the light baking, and this is going to be some look development. I'm going to go for a night view here, or nighttime. So I disable the dome light and increasing the exposure of the camera. And I'm going to turn on the V-Ray interactive rendering. Now, I'm keeping intentionally the two viewports side by side so that you can see how much dramatic change the GI and the reflections are actually, or how much effect they contribute to the real ray tracing illumination, and that you can't trust really the rasterizing viewport yet, because especially in these complex lighting scenarios, global illumination or indirect illumination is key to getting proper results or physically accurate results. So I'm just enabling some lights, changing some parameters until I get to a step that I really like. The important part here is to know why I'm doing this. Usually, if we want to get a really good quality in a real-time engine, we can't escape the process of caching the light in some way, and that's what we call light baking. This essentially means rendering a really good texture for every surface of this project and of every project, and this takes some time. And if I have to do all these iterations one at a time and bake every time, this will be a very lengthy process with lots of time between the iterations. So a lot of artist time would be wasted. So I'm using the interactive version of V-Ray, which updates instantaneously to indicate and see what the light baking result would be without committing to this lengthy process of light baking. You can also use the V-Ray preview, or as I like to call it, a reference rendering or a preview rendering with the full ray tracing effects. You can also use that to add additional effects such as depth of field and change the materials and export high quality resolution, high resolution renders and high quality renders directly from Unreal without having to do either light bake or turn on any ray tracing effects. One other mention here, as you can see, if you use the V-Ray importer, you get to work with the same parameters as the V-Ray materials show you in all the other V-Ray integrations, such as diffuse color, Fresnel IOR, reflections, and so on. So the material interface, as the light interface and cameras, is preserved. I'm going to skip this one. So here are some of the iterations that I saved in the history buffer while I was doing the look development. And I can refer back to that anytime I want. If I want to do the light baking for any of these scenarios, I can revert back and just know that it's going to look exactly like that. Okay, so quickly skip through those. Right, so in the end, once you're happy with the result, with the preview rendering that I showed you, you can go and do the light baking. In this case, I decided to go back to the original artist's intent, which was daytime. So setting up the dome light for baking, which essentially turns it off until the lighting calculation is complete, and initiate light baking. Now, two things happen here. You can see first that the light baking happens progressively, so you can see immediately what's going on. And second, the light maps, once completed, this process takes a few hours, but once the light maps are complete, they automatically get transferred to the engine. And I'm going to do, again, reference render. The left one is the V-Ray ray tracing interactively, fully ray traced, no usage of light maps. The right one are the light maps baked in action. And as you can see, the lighting has been pretty successfully transferred with the V-Ray quality, with the V-Ray lighting algorithms. However, the right one can be played on a VR device at 120 frames per second, depending on your hardware, of course, because all of the lighting has been now cached. And even though it's high quality, it's very, very optimized. Right. So, some things that I didn't talk about, and these are the considerations that you need to think about before, if you want to utilize this workflow. The first thing, obviously, is UVs. These are required for light baking because lighting is unique at each point of every part of your model. So this is why you need to have non-overlapping, properly laid out UVs. This is something that V-Ray will not do for you. We do have a script for 3ds Max that is going to automate that, but for the other versions of V-Ray, there is no unwrapping tool. So yeah, we don't do that. If you want to keep interactive, high frame rate interactive shaders, we do some automatic optimization on import, but it loses some data. So if you want to get a good parity between the original V-Ray project and the one in the real time, you should keep simple shaders. I'm going to talk about this in just a bit. But we also optimize the shaders, and we also give you the option to keep the original complex materials, so that if you want to do high quality rendering, you will be able to do so. So since I'm also coming from an artist background, I know how important flexibility in the original DCC means. And in this example, we have a material that consists of three layers just to simulate a metallic shader. It has two different glossiness values for metal blended with a fall-off map. This essentially simulates a GGX surface. And then we have a greasiness with a dirt map. All of these are really nice effects, but they do require additional ray tracing. And this is something that you don't want to do real time. And the same thing can be just optimized to 4 maps, and it will look almost the same. The same thing goes for this balloon material, for example, which can be represented with a very simple two-sided shader. However, the difference between using the original and the condensed materials, as you can see in the first case, is almost twice as fast to use the condensed material, and the other one is 25% faster. Now, if these are a couple of seconds or a minute per frame in an offline rendering, you wouldn't notice it because it's just a tiny fraction of the time. But if you are looking for real-time feedback, for faster frame rate, every calculation counts, every instruction in the shader counts. So it's always a good idea to go and optimize the shaders if possible. So what else we did? Just 2 weeks ago, we released another update in Viewport Rendering, which actually broadens your workflows. The first and more important one is that we support a vast majority of the Unreal materials, and we can now bake and render those materials without you having to do anything. They just render. Which actually makes it possible for you to render projects that have already been started in Unreal or have been imported using the Datasmith or the Unreal Studio version of Unreal, or just if you take some assets from the market store, from the marketplace, you can just drag and drop them and they will render and bake fine. We also have Viewport Rendering, so that you can see an instant feedback without having to switch between the VFB and Unreal. And we also applied that Unreal tone mapping, which is it's a filmic tone mapping and gives a really nice crush on the highlights and contrast in the blacks, which looks much more realistic. So you can use this one on top of the V-Ray rendering as well. So here is a pretty complex shader in Unreal. It also has material functions and so on. I'm using a material, it's a car paint, obviously, and I'm using the material instance, which allows me to change parameters, and you can see the V-Ray rendering happening in the viewport and rendering the native Unreal material. So you can take advantage of that, and yeah. Here are some objects from the market store with different material parameters. So there is a little bit of diagonal line which splits the screen. The left one is the Unreal viewport. The right one is with the V-Ray rendering. And as you can see, the results are pretty the same. Of course, it's a simple lighting scenario, so we wouldn't expect too much of a difference. To explain a little bit more about the tone mapping. Now this was the Unreal tone mapping. If I use the V-Ray one, you would see that the scene is a little bit overexposed. You have a choice to choose which one to use. It's up to you. We provide all the options. To sum up, we can get you from this, which is the 3ds Studio Max viewport, to import everything in Unreal. This is the regular flavor light mass baking in Unreal. But if you do a baking with V-Ray, you get much more GI, much nicer color bleeding, and a definition in the shadows. Also, another thing that you would be able to do in V-Ray for Unreal is that since you do a light baking, it's a static thing for one time of day, for one lighting scenario. And if I do something like that, which you'll see in a second, animated sky, animated sun, nothing is going to change. The lighting is not moving, it's just static. Now I'm going to show you a rendering with V-Ray per frame. It took about 2 minutes per frame. And see how drastic actually the lighting changes the position of the sun changes the whole lighting. And here is the same rendering, but with automatic exposure and white balance so that we can stabilize. But again, the whole lighting changes very dramatically, and I can use this thing. By the way, this animation was created in Unreal, and we rendered it from the Unreal time sequencer, send it out to the render farm. So I can use one of two things: create a time lapse, time study, or I can also pick up a frame, a time of day that I really like, and see which frame was that, and bake for this time of day, or create a multitude of those. Several key facts. We are currently only Windows based. We utilize every possible hardware on your machine, rendering with GPU and CPU, multiple GPUs, multiple CPUs, and you can also take advantage of the render farm. If you already have one, it uses the universal render node. So yeah, you can scale up pretty nicely. Here are some of the features that if you like the technical side of it, I'm just going to quickly scroll through these guys. The more important things that I wanted to stress here are the resumable baking thing, which is currently in the works and is going to come up with the next update. This will allow you to actually resume baking of a large scene, or selectively bake just an object. Or the really cool thing is that all the light maps per object are going to be as files on the hard drive as DXRs. So you can open these guys in Photoshop and manually tweak if you want to do anything, and actually edit your light maps if you so desire. Now, going on from the other end of the pipeline, where we wanted to do everything ray traced and interactive, and still keep interactivity, and skip all this hustle about unwrapping and setting up things for real time, comes Project Lavina. How many of you are familiar with the Project Lavina? Okay, so for the rest of you, that's a ray tracing engine that's intended for you to get real-time previews. And is geared towards very high dense data sets, very complex, lots of polygons, lots of textures, heavy ray tracing. It works without any necessary preliminary steps like unwrapping or simplifying shaders and stuff like that. And it works with V-Ray scenes that can be, again, as if you remember, they can be exported from almost any integration of V-Ray, and run best on the RTX because it takes advantage of the ray tracing course. Now, I've taken the liberty to export the V-Ray scene from Unreal, the same scene that you just saw. I'm just going to change the sun so that we can see some kind of a change. And export a V-Ray scene from here, and then load that in Lavina so that you can see what the same scene looks like in Lavina. So that's Lavina working. It loaded pretty fast, and currently it's ray tracing in real time, where you can just see that the parity is again quite there. But we didn't need to do any light baking, nor unwrapping, and so on. I turned off the denoiser on purpose so that you can see how quickly it converges. That was recorded in 2080 very entry, or not very entry, but middle ground. It's not a TI, and it's only one. So it can give you the idea of what the performance is. Here is a better demo of Lavina that was recorded on a 2080 Ti with the denoising enabled right. Here are some important things that to know about is that we try to keep scene hierarchy and the objects separate, so you can hide behind them, you can manipulate them, translate, rotate, scale. The basic transformation tools are enabled for you. If you have animations, for example, the sun, you can scrub through this animation and see again everything updated in real time. But as you can see, all the shadows and GI and everything is updated as you interact with your scene. And you can see the frame rate up there on the left. All right. Again, the important part here being is that is dedicated as you can think about Lavina as a VR scene viewer with the option, with the added layer of a little bit of interactivity. All right. Finally, I wanted to mention that the doors are not closed when you go. It's not a one-way street into Unreal. You can still export the same VR scene. Actually, I just showed that, so apologies for the duplicate export. But you can just export a VR scene out of Unreal and import that not only in Lavina, but in this case, we'll go into Rhino and import that VR scene over there, which successfully actually allows cross-platform interoperability. I'm going to show all of the faces here. And as you can see, all the geometry was imported, and I'm going to do a render in just a bit where you can see all the materials and the light setup, by the way. The only thing that was not migrated was the camera settings, so I'm going to adjust the white balance and the exposure in a bit. And you can see that the result is pretty much the same. All right, so as you can see, this opens up quite a lot of functionality. So this is where we want to go. One thing I would really like to point out is that we want to hear from you where do you think this should be going, and how we can improve on that, because these are just some interesting functionalities that we thought of, but it means nothing if it's not useful for you. So we would really love to hear from you. If you have any questions, suggestions, and just want to give us a shout out, please. You can reach us over there, and we'll also be there in the Darwin room on floor 5. So you're welcome to chat about everything. Thanks for watching.
Questions for Simeon? We've got a few minutes over here.
You mentioned the light baking in Unreal Engine. Thank you. Thank you for the presentation. It looks very exciting to see a V-Ray sort of level of quality on the lights, and particularly in the light baking happening in Unreal Engine. So does that mean that we control the settings for the quality of that light that's being baked in V-Ray or through a V-Ray separate tab? Because in Unreal, normally you have quite a detailed breakdown of light bounces, light map resolutions, textures, and so on. Are you using that, or V-Ray has a separate, let's say, settings in order to determine the quality of the light that is being baked?
I understand, yeah. We didn't want to complicate the workflow in Unreal. It's already complex as it is. And also V-Ray is known for having a lot of settings, so we try to keep the settings to a minimum. Basically, you have only quality control settings globally in V-Ray, while the rest of the settings are taken from the Unreal properties as much as possible. We don't do shadow maps. We're just rendering everything, global light maps. So the individual settings per light, per quality are not needed actually, but you can control things like radius, colors. The artistic parts, the artistic parameters for lights are taken directly from the interface, while the quality settings are taken from the global settings in Unreal. In V-Ray.
That's okay. So it's the global settings.
Yes. Yes.
It doesn't matter what presets we have on the global settings in Unreal.
No.
Baking, it's a separate one.
No. We actually went one step further, that we already have a complaint. Alex Roman actually told us that we stripped down the settings too much. We do have one control that says quality, and it's a slider which has 3 settings. So yeah, probably we did overdo it there.
Sorry, just one more question. One more question being,
Yeah.
you mentioned it takes quite a long time for those lights to get baked and calculated.
Yeah.
V-Ray has V-Ray Cloud rendering capabilities. Is it possible to distribute some of that baking into multiple machines, or it's always happening natively on the one processor of the computer?
Right. So as I mentioned, we take all of the hardware that is possible on the current machine, and we also support distributed rendering. So you can utilize a render farm if you have one locally. Cloud rendering is not yet supported, but this is definitely on our to-do list and is going to be available. I can't commit to a deadline, but probably in half a year, something like that.
But if we do have a local render farm with loads of CPUs, we can make use of that for the light baking in order to speed up the process.
Absolutely. CPUs, GPUs, whatever you have, just give it to V-Ray for Unreal. It will crunch it.
So since everybody else has asked this question, do you want to talk a little bit about pricing and packaging for V-Ray for Unreal Engine?
I have to be ashamed a little bit because I'm not sure about the price.
I've put you on the spot.
Yes. I think it was $350 per year per seat, something like that. But don't quote me on that because I'm trying to find out what is better for the product, and I leave the business side on other person. I come from an artistic background. Hopefully that's an excuse for me.
It's a very good excuse.
But yes, it's a subscription only. That's important, and we do have monthly and yearly rental. Yeah.
Excellent. Thank you. Time for one more question. Going once. Going twice. Here we are.
Hi. The other product you showed, Lavina, is that how you pronounce it? Lavina?
Which one, sorry?
Lavina?
Yeah, Lavina. Yeah, it means avalanche in Bulgarian.
Cool. So is that like a tech demo, or is that going to be available somehow? How's that going to?
It's definitely happening. It's going to be a product, a fully fledged Chaos Group product. We might also make it as a separate mode of V-Ray. We don't know yet where this is going. We still want to get feedback from you guys. See how do you see it? Where do you see it fit in your pipeline? And if you want to have more information, again, just contact us. We may be able to provide more information once we figure out what do you want to use. What do you want to use it for? But yeah, the idea is that we are definitely making it. We're not sure if it's going to be a separate product or a part of V-Ray.
Thank you.
You're welcome. Thank you.
Thank you very much.